So again, this is the homework for tonight and tomorrow night. So now, these were some common questions that I had while doing tutoring. So these are the ones I'm going to focus on going over first. Now, on page 91, there are two questions there. There's question 11 and 14. So let's go there first. Thank you. So on page 91, let me flip over to 91, 11 and 14. So we're looking at the questions down here at the bottom. Now, for 11 is asking us about two lines, and they just want to know, are these two lines perpendicular? So for this diagram down here, we can find the slope of each one of those lines. So let's just do all three lines real quick. If I go AB, I go up 2 and over 3. So my slope for AB, ooh, that's not the right way to write that. Segment AB slope equals 2 over 3. Then, if we look at the next line, so let's say CD or DC, because that's how they write it most of the times. So looking at the slope for CD, we would have up 3 over 3. So up 3 over 3. That would give us positive 1. If we did the slope for AD, so going down and then over, whoops, I went too far. Sorry. Down and then over. So we went down negative 3 over positive 3. So AD's slope would be negative 3 over 3, which reduces to negative 1. So let me scoot that over so you can see what I just wrote. Now, on there, we need to see whether or not, for number 11, are these two perpendicular? Well, for AB and for AD, those two are not opposite reciprocals. So those two are not perpendicular for number 11. But what is going to be perpendicular would be number 12, because these two are opposite reciprocal slopes. Therefore, we can say that DC is perpendicular to AD. Remember, opposite reciprocal slopes, if you were to multiply the two numbers together for opposite reciprocals, they should equal negative 1. All right? So 1 times negative 1 is negative 1. So those are opposite reciprocals. Now, if you look at 14 on that same page. So number 14, we have 14 is a right angle. If RS has a slope of 3, what must the slope of ST be? Well, if one has a slope of 3 and you have a right angle, again, we have a right angle. That means that the two lines are perpendicular, right? So RST, these two lines are perpendicular. Therefore, they should have opposite reciprocal slopes. So if this one has a slope of 3, the other one must be the opposite reciprocal of that. So we take 3. If we put it over a fraction, it's 3 over 1. And then you have to flip it and do the opposite reciprocal, so you get negative 1 over 3. So that's your answer for 14. Negative 1/3. Any questions there? All right. Going on to page 96 then. On page 96, now, a lot of these are the same. Some of these give you more information than others, but you can leave most of these equations in point-slope form. So it's important, first off, that you know your two formats for this. So let me go over our formats that we're using here. We can either use slope-intercept form, which is y equals mx plus b. Or we can use point slope form, which is y minus y1 equals m times x minus x1. Because some of these, it's just a matter of plugging the values in and getting your answer. So let me move this over. I'm going to write my answers off to the side here. So for number 16, it says, what is the equation of a line parallel to this? Well, if it's parallel to this line, it's going to have the same slope. So on number 16, I know that my slope is going to be the same as what it is here. And this is in slope-intercept form, so I can see the slope is -3. They also give me a point, which is at 6, 8. So I'm going to use the slope and the point and plug it into point slope form. So I'm going to do y minus y1, which should be the 8. So again, this would be my x1, y1 when I plug it in, equals the slope, -3, times parentheses, x minus x1. And I can leave my answer just like that. I don't have to go any further. Now, if you choose to change it to slope-intercept form, you could. Again, you don't have to go any farther than that. You have an answer. If the question asks you to leave it in slope-intercept form, then you could go the extra steps and change this to slope-intercept by solving for y. So if we wanted to, we could first distribute the -3 and then bring the 8 over to the other side by adding, and you get positive 26. And this would also be an acceptable answer. So your answer could be in either of those two formats. So either of those two formats would work. Now, on number 17, same type of thing. But on 17, we have perpendicular. So we have a slope, but the slope in this one, since it's going to be perpendicular, has to be the opposite reciprocal. So instead of doing 1/4, our slope that we're going to use is going to be -4/1, or just -4. Our point that's given to us, -2, 4. So again, plugging it into that format, we have y minus 4 equals the slope, -4, times x minus -2. So minus a negative becomes plus a positive, so we can say x plus 2. And again, I could leave it just like that. That could be my final equation. Or, if you want to change it to slope-intercept form, you could by distributing that -4 and then bringing this 4 over to the other side. So you just solve for y. So this would be -4x minus 8. Bring the 4 over by adding it. You'd have -4x minus 4. And then again, that would be another acceptable answer for number 17. Any questions there? All right. The other one that you guys had asked for was number 3 on page 97. So on page 97, you have a diagram that you're using for problems 3 through 6. So on number 3, it says, the drafter needs to confirm that AG is parallel to CD. So here's AG, there's DC. Again, you can just use the graph and see, hey, we're going down and over. How many units? 1, 2, 3, 4. We went down 4 and over 2. So our slope for AG would be -4/2 or just -2. For CD, again, we're going down and then over, so down 4/2. It's the same slope. CD slope, -4/2 or -2. It's the same slope, therefore they are parallel. So, yes, they are parallel because they have same slope. And that's it. Are there any other problems that you guys wanted me to go to from any of those sections? Yeah.
13.
Which one?
13, question 13 and 91.
13 and 91.
On 91.
All right, let's see. So I'd done something from that. Let me see what it was again. All right, 13 from 91. Okay. So on that one, it says line L. So this has nothing to do with the figure over here, right? So it just says on 13, line L passes through the origin and point 3, 4. So if you want to, you can draw a picture. Remember, origin is at the point 0, 0. The point 3, 4, you're going to go over 3 for x value, up 4 for a y value. So that's at our point 3, 4. Now, when you do slope, though, again, slope is the opposite of when you're graphing a point. So we're going from this point to that point. We're going up 4 units and over 3 units. So for our slope of this line, our slope is going to be 4 over 3. Now, since on 13 they're asking for the slope of a line parallel to L, it's going to be the same slope. So that will be our answer for number 13. And that's it.
Thank you.
Any others? Yeah. 97, number 6. 97, number 6. So 6 is also using the same diagram that we were just using a few moments ago. Make sure I can fit this whole thing up there. So using that diagram, it said name a segment that is neither parallel nor perpendicular to BC. So if we look at line BC, BC is this line right here, right? So if we go up and over, this has a slope of 2, 4. So again, BC has a slope of up 2 over 4, or if we reduce that, positive 1/2. So you need a line that does not have a slope of 1/2, and it cannot have a slope of -2. So an easy one to do would be your vertical lines. Any one of those vertical lines would be an easy one to pick. Now, there's other things that you could probably choose from, I think. Let's see. Is there? That one, perpendicular, parallel. Actually, no. So on this one, you have those other two are parallel. These other three are perpendicular to it. So they'd have to be the vertical lines.
So they can't be connected. They don't have to do anything with these.
They don't have to be connected in order to be parallel perpendicular. Because remember, it's talking about a line, right? So your lines are going to be, like anytime you're talking about perpendicular, you're talking about the line that it's on. So although it only draws it as segments, again, they will eventually connect when you're talking about the lines.
So can you do FG?
So FG would be a good example of one that would work. So any of those vertical lines, so you could either say FG, DE, or AB. Or list those in the opposite order, and those would be fine as well. So that's for number 6. Number 2, same page? Let's go up to number 2. Number 2, line M contains points with coordinates, and they give us 2 coordinates, and line N contains points and coordinates with, are the lines parallel, perpendicular, or neither? Justify your answer. So first thing we'd have to identify is the slope of those lines. So on there, for line M, we're going to figure out the slope. So we're going to do 8 minus 1 over 5 minus -4. They didn't give us a graph, so now this is a good time to use our actual formula for slope, which again is y2 minus y1 over x2 minus x1. So 8 minus 1 is 7. 5 minus -4, that becomes plus a positive, so that'd be 9. And then we have to find the slope of the other line, so line N. So line N, the slope for that one, same thing, we're going to do 7 minus -2 over 10 minus 6. 7 minus negative 2, that would be positive 9, because again, that becomes plus a positive. 10 minus 6, that becomes 3. That one we could actually even reduce down to just positive 3. Oh, what? Yeah, sorry. Ignore Mr. Spizak, he's going crazy. 9 over 4, you can't reduce that. But now, are those the same? No, so they're not parallel. Are those opposite reciprocals? No, so they're not parallel. Sorry, they're not perpendicular. So again, since they're not the same, they're not parallel. Since they're not opposite reciprocals, they're not perpendicular. So this one would be neither. Yeah. No, that's all right. 9 and 10 on the same page. 9 and 10. So you're using the diagram this time. So what is the slope? Let me find my blank sticky notes here. I'll put it to that edge. So for 9 and 10, we have, what is the slope of a line parallel to S? So first thing you have to determine is, what is the slope of line S? So this is line S. Now, they gave us this point and that point, so we could go all the way from that point to that point. Or if you found other points that you can tell it intersects with, you could use those as well. But using these, 1, 2, 3, 4, 5, 6, this goes up 6 units and over 2, 3, 4, 5, 6, 7, 8, over 8 units. So for line S, the slope is up 6 over 8, or if we reduce it, those are both divisible by 2, so we could say 3 over 4. So now, what's the slope of a line parallel to S? So for number 9, if we're doing parallel, it's the same thing. So you could say either 6 over 8 or 3 over 4. For number 10, they want a slope that's perpendicular to line S, so that's where you do opposite reciprocal. So either negative 8 over 6 or negative 4 over 3. Those would both be acceptable answers. Again, you should really reduce, so it should really be this last one that I put up there. All right.
So it would always want you to simplify it, even though they want S.
You should always write your slope in simplest form. Yes.
Okay.
Yeah. For almost all math things, you should always simplify if possible.
Okay. And
Yeah.
a lot of the answer choices have both the simplified one and not simplified.
They shouldn't have both. Now, could they on like a select all that applies?
Yeah.
Yes, they could.
But then you pick both.
Then you'd pick both. Yeah.
Okay.
And I can't say for sure if I've seen that on like the FSA, but I've seen that on other computer-based tests where like you have multiple answers that are the same slope, just one's simplified, one's not. It could happen. So yes, if it's a select all that apply, you could have a simplified version and an unsimplified version, and they'd both be correct answers.
Okay.
All right. Any others that you want me to go to? I'm going to go ahead and stop this recording so I can post it for